Namaste, children. A warm welcome for all of you. I am T.K. Prasanna Murthy from Bangalore. I am a retired high school teacher from Bangalore South. I have served one of the prestigious institutions of our state. It is none other than Vijaya High School and Vijaya Composite College. I had the privilege of serving this institution for nearly 36 long years in the mathematics department, and I got my retirement in the year 2016, May 31st, and I had the privilege of working as the head of the institution also. The last 2 years of my service I served as head of the institution of that esteemed institution. Dr. Basavalinga Pattadevaru from Balki, Bidar district, Hiremata Samsthana, with his great vision and blessings, we are starting a bridge course for the IIT students who have just completed they wrote the 10th standard SLC examination. So I am going to share some of my experiences with you, children. So I have planned this way. I wanted to share, to begin with, one of the fundamental unit of geometry. It is none other than definitions, axioms, postulates and rules of Euclidean geometry. This I wanted to share today. So before I begin, I wanted to immensely thank Basuraj sir, a young man, a young principal of this great institution, who is working day and night for the betterment of the students community. So he has taken a lot of interest in making this program to happen, this program. Sir, really thank you very much for this great opportunity that you have provided to me. Children, whatever I wanted to convey you, it's in PowerPoint. So I will shift to PowerPoint, students, now. Okay. Yes. So we are discussing today now geometry. Children, you know geometry, the word geometry consists of two words, geo and metrian. Geo means earth, metrian means to measure. We wanted to measure the land, how much we have gained or lost. Okay. So this is the main scope of to measure the area of a land that I possess. That is the main subject of geometry. So these are the two Greek words. I wanted to briefly tell you there are many branches are there in geometry. I wanted to just make a small list of this. Whatever geometry that we have studied from our first standard to 10th standard is called Euclidean geometry. Euclid, the first person to write books, 13 volumes called the Elements, with 465 propositions. It's called plane geometry or Euclidean geometry. Then the next one branch of geometry is non-Euclidean geometry. So like this the list goes on: algebraic geometry, analytic geometry, differential geometry, projective geometry, Riemannian geometry, and there are More than 40 branches are there now. So here is a very big list arranged as per the alphabetical order. Many branches are there. Since you are IIT aspiring students, I think some of you may take this as one of your research projects in your future. So let us begin our study today, children, by recalling the great top 10 ancient Greek mathematicians. Here is a list. So the columns are there: serial number, name, period, and place. The first person who started this kind of thinking or writing, whatever we do, in geometry, is because of Thales only. He may be called as the father, who initiated this kind of a thinking in us. He is from Miletus, around 600 BC. And he is followed by Pythagoras. What a great student of Thales, and how Thales is fortunate. So Pythagoras was the student of Thales. Then Socrates, Plato, Aristotle, Ptolemy I. Then came Euclid. Then followed by Archimedes, Proclus. He is under AD. He comes after BC only. So the last one is Heron, also from Alexandria, Egypt. So these are the top 10 ancient Greek mathematicians. In fact, there are many more are there, but these are very popular ancient Greek mathematicians. And you can see in the list, before Euclid, there are so many stalwarts. So because of them only, Euclid could collect, understand, and he could classify them into 13 volumes, and hence he was able to produce the first ever textbook in mathematics, the Elements. And the last important Greek philosopher is Heron only. This is the first page of the book called the Elements. Yes. Now, let me tell you in this slide, in 13 volumes, there are about 465 propositions are there. So these are the volume numbers and the content. Perhaps we may be under the impression that the book Element consists only of geometry. So I think this slide will help you to understand that not only geometry, he has also written lots of things about number theory in 5 volumes, and then solid geometry also. So you can see the volume numbers and the content. So the main 3 subjects of the book Elements is plane geometry, 5 volumes, number theory, equal number, 5 volumes, and solid geometry also. Now I need not tell you this, but still I just wanted to tell you, if you want to start any subject, in the beginning you have to start from definitions only. In Sanskrit it is called Vyakyanagalu. In Kannada also Vyakhyana. Then we have to understand axioms, Swayam Siddhantagalu, followed by postulates, and rules, if any. Then with all these 4 things we can understand theorems or propositions. Once we understand the theorem, we have to go for converse also. That's called Viloma. Then corollary, if any, and this is the path to success. So with this background, let us try to understand the 23 definitions given by Euclid in volume number 1. So if you want to achieve any success, this is the path to success. Keep this as the road path to success. In our 9th standard textbook, please remember, in CBSE textbook I am talking, there are 7 definitions are given out of 23. In fact, in the volume number 1, he has given 23 definitions. But in our textbook, CBSE textbook, only 7 definitions are given, followed by 5 postulates and 5 rules. Okay. So this is the aim of the first 2 or 3 my sessions, children. Okay, let me begin with definitions. So this is in volume number 1, the elements. So altogether there are 23 definitions are there. Okay, yes. Now, can you tell me what you mean by definition, or can you define the term definition? Okay, so here is a small effort to give you the meaning of the word definition. Definition means precise meaning, exact meaning, vyakya. Okay, so again this word vyakya, which is Sanskrit, has got 2 words, that is kya. Kya means prakatane, to make announcements, and vya, when add to k, it will become special information. Okay, this is the meaning of definition. ವಿಶೇಷವಾಗಿ ತಿಳಿಸ್ತಕ್ಕಂಥದ್ದಕ್ಕೆ we say ವ್ಯಾಖ್ಯಾನಗಳು, ವ್ಯಾಖ್ಯೆ. In English it is called definition. Okay, so these are the 3 important characters of vyakya. It should be ativyapti, it should be avyapti, and it should be asambhava. So these are the 3 features of a good vyakhyana or definition. So can we put it this way, children? A statement, definition means a statement showing the meaning of word, word group, sign, symbol in other terms which are supposed to be well known. Whatever we know, using those terms only, we are going to give the meaning of the word or group of words or sign, symbols, whatever may be. So that is statement which gives us the complete meaning is called definition, and it has to be very, very precise. Precise means it should be exact, correctly and completely. It should be complete, it should be correct, it should be exact. Such a statement is called as definition. Okay, there are some rules to be followed if you want to define a word. It must set out the essential attributes of the thing defined. This is the first condition. Attribute means a quality or characteristic that someone or something else, that lakshanagalu, that qualities, that should be very clearly defined. The next one, it must avoid circularity. It should be free from flawness. Okay, so disagreement, there should be no conflict or no disagreement. It should not have such flaws. And the third one is, it must not be too wide or too narrow. Okay, this is the third rule. And it must be obscure. Okay, means that it should be very, very clear. There should be no uncertainty. Okay, spashtavagi helillada, that should be totally avoided. It should not be negative where it has to be positive. So these are some of the rules. If at all you wanted to define, keep these rules in your mind and try to define things in physics, chemistry, maths, in any subject for that matter. I am remembered of Swami Dayananda Saraswati, who lived in the 18th century. He has written Aryodesha Ratnamala. This book contains the meaning of 100 words. I understand that Swami Dayananda, if you want to give any lecture, prior to that only, he used to give in writing the definitions, the meaning of the words that he is going to use in his lectures, so that the audience will be very, very clear, so that they can understand what exactly he means that. So in the same way, let us try to define certain things which are very, very, very important to understand geometry. Okay, that is our theme now. Now comes the 7 definitions in geometry. Okay, so the 7 definitions are about the point, line, and surface. Okay, so these are the 3 concepts about which 7 definitions are there. In definition 1, he says something about very clearly what is a point is. And in definition 2, 3, 4, it's about a line. Okay, it clearly defines what a line is under definition 2, 3, and 4. And 5th, 6th, and 7th definition is about surface. So these are the 3 concepts, the words that we very frequently we come across in geometry. So he defines these concepts very clearly in 7 definitions. Okay, now the time has come to understand definition number 1. Are you ready, children? Okay, a point is that which has no part. What do you mean by part? Part means length, breadth, height, thickness, whatever might be. It has no dimension, it has no length, no breadth, no thickness, nothing. Such a simplest figure in geometry is called a point. So a point is that which has no part. So if you use a sharp pencil and keep a dot on the paper, it will have some amount of the dimensions. So it is not at all a point. So it is just a representation of a point and not a point. So this is definition number 1. Okay. Now let's go to definition number 2. So you can read it in Kannada also. ಒಂದು ಬಿಂದುವಿಗೆ ಯಾವುದೇ ಭಾಗವಿಲ್ಲ. Okay, definition number 2. Here is definition number 2. A line is breadth less length. Wow. So a line has only one dimension. It has only length, no breadth at all. Is it possible to draw a line in such a case having only length without any breadth? Definitely not. It is impossible to draw a line. However sharp we draw, it will have some amount of breadth. But a line in the real sense has no breadth at all. It has only length. So whatever we draw using scale and pencil, so it is just a representation of a line, but in the real sense it is not at all a line. This is definition number 2. Okay, now let's go to definition number 3. The ends of a line are points. So a point, a line, in fact a line is nothing but union of, collection of infinite number of points. They put together, it forms a line. So in the beginning there is a point, in the end there is a point, in between those two there are infinite number of points. So definition number 3 says that a line consists of infinite number of points from the beginning to the end. So the ends of a line are points only. This is definition number 3. Okay. Now definition number 4. Okay. A straight line is a line which lies evenly with the points on itself. So definition 4 says something about a straight line. A line can be a straight or curved. So when we call a line as a straight line, so that can be understood if you read definition number 4. It states that a straight line is a line which lies evenly with the points on itself. Look at that word evenly. In a steady or a regular way. Or we can say, if the entire set of points of a straight line must be on a single plane. You know, a line is nothing but a collection of infinite number of points. If all those points are on one single plane, then such a line is called as a straight line. Okay? Again, think for a while, is it possible to draw a straight line, children? Because whatever surface we draw it, it is not a plane surface at all, it's a curved surface. So in the real sense, we cannot draw a line, first of all, and next point is, we can draw a straight line also. These are only concepts. So if all the points that forms a straight line, if it is on a single plane, okay, then the straight line, then the line is called as a straight line. Otherwise, it is called as a curved line. Okay, this is definition number 4. Yes. Now, the same thing for a straight line, many others have strayed here. So, I wanted to quote Leibniz. He defines a straight line like this. Okay. He is from Germany, who lived in the 16th century. Okay. He says a straight line is one which divides a plane into two parts, into two halves. This is his definition. In the later, after BC, many mathematicians have tried to define in their own ways whatever Euclid has done. Here is the one, Leibniz, a very popular mathematician from Germany. He says a straight line is one which divides a plane into two parts, into two halves, and that is called as a straight line, identical in all but position. Okay, each part is called a half plane. This is another important concept, half plane concept, given by Leibniz. Okay, Legnerade also, he also has tried to define a straight line in this way, children. Okay, he is a French mathematician, and he says a straight line is the shortest distance between 2 points. Look at this definition. He is opening another important phase of a straight line. So what is a straight line according to Legnerade? He says it is the shortest distance, the minimum distance between any 2 points, and that shortest distance he calls it as a straight line. Okay, now the same thing you are seeing in Kannada also. Okay, now let's go to definition 5, which is about a surface. So now he says a surface is that which has only 2 dimensions. One is the length and another is breadth. Okay, a surface is that which has only 2 dimensions, that is length and breadth. So a point has no dimension, no length, no breadth, no thickness, nothing, whereas a line has only 1 dimension, whether straight line or curved line. But now the 2 dimensions we are talking, we have come to 2-dimensional figures. A surface is that which has two dimensions. One is the length and another is the breadth. No thickness at all. Okay. So that is how we define a surface. So in surface we have got two types, a curved surface and a plane surface. So this is definition number 5. Okay. So that is in Kannada. Okay. Now 6th definition. The edges of something about surface only. The edges of a surface are lines only. So the boundary of any surface are lines. Lines means it may be straight lines or curved lines. Okay. So if you take the surface will have edges, it will have boundary, and the boundaries will always be lines only. Okay. So a line means a single dimension, only length, no breadth. So that is the edges of a surface. This is definition number 6. Okay. Let's go to the last definition from our textbook. Okay. Now he says something about a plane surface. Okay. What do you mean by a plane surface? A surface is called a plane surface if which lies evenly with the straight lines on itself. What do you mean by this? How to understand this, children? So look at this. Just hear to listen to me. If we can draw straight lines on any surface, then such a surface is called a plane surface. If you cannot draw straight lines on a surface, if you can draw only curved lines, then it is not a plane surface, it is not a flat surface. A plane surface means a perfectly leveled, flat surface. Or definition number 7 says, if you can draw straight lines, okay, means the straight line means infinite number of set of points. If all those set of points which makes up a straight line, if it is on a one particular surface only, then that surface is called as a plane surface. So if we can draw straight lines on a surface, then such a surface is called a plane surface. Once again, children, there is no surface in this universe where it is absolutely plain. You may say that the surface of a plane mirror. No, children. If you look at some particular angle, okay, in an oblique plane, if you can see so many curvature on that even the flat mirror also. Say, if the water in a pond is in the still position, in the equilibrium position, then look at the top layer of that water. For a distance, it looks as if it's very, very flat and perfectly flat, and it is plain. Because of surface tension, you can see if you see from one side, you can see a lower meniscus. It is not a plane surface. So there is no surface which is absolutely flat. It is just an abstract concept. Okay. So a plane surface is a surface which lies evenly with the straight lines on itself. I think for the second time we are encountering the word evenly. So please try to recall the word evenly. Okay. So let me sum up all these definitions, children. Definition 1, definition 2. You can read for yourself all the 6 definitions you can see in one single slide. So these are the 7 definitions which one has to remember if you really wanted to understand, enjoy, appreciate the subject geometry. Okay. So the first three is about a line, and the next three is about the surface. You can make some classification like this. Definition 1 is about point, and with the help of point he tried to explain define line, and with the help of those two he will try to define surface and the types of surfaces. This is how he has planned the first 7 definitions. Okay, the same thing you are seeing in Kannada also, children. Okay, fine. From 8 to 23, there are more definitions are there. Here is a small information for you, children. So 8, 9, 10, 11, 12 definition is about angles. 13 and 14 definition is about boundaries, and 15, 16, 17, 18 definition regarding circles, 19, 20, 21 is about regarding triangles, definition 22 is about quadrilaterals, and definition 23 is about parallel lines. I sincerely advise and request all of you to go through the remaining definitions so that you will have a very clear understanding of this subject. Okay, now let me close this file, children. So this is a brief introduction about the 7 definitions from our textbook. Okay, so having understood definitions now, children, I am very eagerly waiting to discuss with you about the axioms. About 5 axioms he has given. I wanted to share it with you. And if you have any queries, any doubt, any difficulties, you can contact the principal of your college, or you can just message me in WhatsApp, and I shall try to clear your doubts as far as possible to greater extent. Okay, now let me go to axioms, children. Okay, yes. Yes, here is the 5 axioms. In fact, there are 7 are given in some books. So, Euclid in his book Element, he has not used the word axioms. In fact, he has used common notions. Under common notions, he discussed the axioms. So let us try to understand the word notion first. Notion means a conception of or a belief. Okay, we will have some idea in our mind regarding the practices that we follow in our usual works. So that is called notion. So in geometry, there are some common beliefs are there, common conceptions are there regarding this subject. So we have called them as axioms, but Euclid has called it as common notions. Okay, let me try to tell something about this. The common notions are evidently the same as what we termed axioms by Aristotle, who deemed axioms the first principle from which all demonstrative sciences must start. Children, it is a very important slide. If you want to start, if you want to begin any study, please, for heaven's sake, start from definitions and then go to axioms so that you can really understand the subject. Okay, so this is the view by Aristotle. Okay, Siddhanta in Sanskrit, this is the right word for axiom, Siddhanta. Siddhanta means a set of beliefs or principles that influence the way people live or work. Okay, with certain beliefs only we work in our laboratories or in our house also. We have some principles and beliefs on which we conduct ourselves. So it is called doctrine. It's also called as a doctrine, is a set of principles or even it's called as an ideology. Okay, so some more informations are given here. I am going to skip all these slides since we are running short of time. So axiom means swayam siddha. Okay, swayam means tanagi, tane, tanu, and it's quite evident. Okay, that is the meaning of swayam siddha. Means that is axiom. Okay. Now here is, I wanted to tell you what do you mean by an axiom or swayam siddha. It is a scientific statement which is accepted as true without any logical proof, okay, and applicable to many branches of science. See, this is the meaning of the term, the concept axiom. Axiom means it is a scientific statement. You cannot question them. You cannot doubt them. You cannot argue them. You cannot question them. Okay, without any arguments, without any making any debate, you have to simply accept them as a true statement, and such statements are called axiom. And axioms are not only applicable to geometry or physics or chemistry, in so many branches you can apply them. So such scientific statements are called as axiom. So we have defined 7 definitions. Now we are talking of axioms. Okay, so let us try to understand the term now proof. Without any logical proof, if you accept, such a thing is called as axiom. So here is a very, very beautiful meaning for the word proof. What is proof? In 8th, 9th and 10th standard we have proved so many theorems, we have written proof for so many theorems. So proof is nothing but it is a step-by-step procedure of establishing the truth of a statement. Okay, if you want to prove, there are so many stages are there. So step by step we are going to write down our argument with the help of our previous knowledge, by which we are able to uphold the truth of a statement which we wanted to establish. So that step by step procedure is called as a proof. So proof is nothing but a procedure, a scientific procedure, argument of establishing the truth of a statement. Or children, can you see this, children? Proof is nothing but it's a process that convinces a skeptical adversary. What do you mean by skeptical and adversary? Sorry, skeptical means tending to doubt. You may be doubting how this is possible. A cyclic quadrilateral is a quadrilateral in which the sum of the opposite angles is 180. Oh, if the sum of opposite angles in any quadrilateral is 180, then it becomes a cyclic quadrilateral. You may be doubting how this is possible. The sum of opposite angles, and that is making it to be a cyclic quadrilateral. And after listening to the proof, your doubt will be very much clear, and you will be convinced. So such process is called as a proof. Okay, skeptical means you will be doubting. You may be saying that it may not be possible. Okay, adversary, or before that, skeptical means not to believe what other people tell you. Okay, adversary means fighting or competing against a component. Here is a student who may say, sir, how it is possible? I don't think it is possible. He may say that. But after listening to the proof, he will only say, sir, whatever the statement we have made is 100% right. So such a process is called as a proof. So that is the meaning of convincing a skeptical adversary. So such a thing is called as a proof. Okay. Now the word logic also is very, very important. So our geometry is full of logic. So look here, children, the word logic, it is a science. It is not just science, it is art and science of arguments. Okay, that branch is called logic, tarka in Sanskrit and Kannada also. Okay, tarka baddhavagi, logical. Okay, now look at this slide, a very important slide, wherein I have collected fundamental qualities of an axiom by referring to all the dictionaries available in our library. An axiom is nothing but a formal, means done in accordance with rules and convention. Concise means precise, short, clear, with no unnecessary words, popularly accepted. It is not accepted by only one religion or community or country. It should be accepted in the entire universe. This is the third quality of an axiom. It is formal, it is concise, it is precise, it is accepted throughout, and then it is obvious, okay, easily understood, clear, apparent. The moment we make this axiom, you will only say, yes sir, it is true, it is beyond doubt, it is scientific, it is accepted, okay, no flaws are there. That is called obvious, easily understood, clear, apparent, accepted without question. Without questioning, without argument, without doubting, we simply salute and say, yes, it is a true statement. It is universal statement. This is the fifth quality of an axiom. A general, a true statement, and it is applicable to many branches of science. And the main purpose of doing all these is we wanted to develop a theory, construct a theory. So if you want to construct a theory, you should have axioms only. With the help of these axioms, we can develop or construct a theory in which theorems may be derived by its rules of its inference or conclusion. Look at this beautiful slide, children. So these are some of the good qualities, important qualities of an axiom. It is formal, it should be concise, it is popularly accepted by everyone, obvious, accepted without any questions. It is a very general, in the sense it is applicable to all the branches of science, and it is a true statement, pakka true statement, applicable to many branches of science. And the purpose of the axiom, to develop axiom, is we have kept some theory in our mind. If we want to put forward a theory, we need the help of axioms. Okay, and once the theory is developed, from that we can clearly define, we can find out the theorem by the rules of its inference. So this is one piece of information for you. This I could collect by referring to so many dictionaries available in our school. Okay, now the time has come to see axiom number 1. The numbers are also universal. Okay, axiom number 1 is this. Okay, states things which are equal to the same thing or equal to one another. See, this is axiom number 1. So without any question, okay, we simply accept yes. So if I add equal quantities, if the things which are equal to the same thing, definitely they should be equal to one another. Without any doubt, we say this. Okay, this is in Kannada. Okay, so you can understand this in this way algebraically. If A is equal to B, so this is left hand side, that is right side. So A is equal to B, and A is also equal to C. The left hand side is also equal to another quantity, another variable, say C. So if A is equal to B and A is also equal to C, then we can say definitely the two right hand sides B and C are equal, because B and C are equal to the same quantity A. Therefore B must be equal to C, or you can say this also, all the three quantities A, B and C are equal. This is the meaning of axiom number 1, which states things which are equal to the same thing or equal to one another. See, A is the quantity to which B and C are equal, so therefore B and C must be equal. Okay, or we can, the same thing we can put it this way also, children. So look at the beautiful way in which you can write this. If A is equal to B and B is also equal to C, then definitely A has to be equal to C. Correct? This is the meaning of axiom number 1. So B is common. So A is also equal to B, C is also equal to B, then definitely A and C are equal. Okay, now look at the applications of axiom number 1. So many places we have used this axiom. Here are one or two illustrations where we have applied axiom number 1. Here is a right angle triangle ABC in which angle B is 90 degrees. BD is perpendicular to AC. Okay, this is the symbol for 90 degrees. Okay, in right angle triangle ADB, angle ADB is 90 degrees. So let us call angle BAD as number 1 and angle ABD as number 2, and definitely we can say in right angle triangle ADB, angle 1 plus angle 2 is equal to 90, because it's a right angle triangle. The two are complementary to each other. Okay. Now look at the triangle BDC, another right angle triangle BDC, in which angle DBC, let us suppose that it has angle number 3, and angle 3 plus 2 is also equal to 90 degrees. Okay, because angle ABC is 90 degrees. Now angle 1 plus angle 2 has to be equal to angle 3 plus angle 2. So angle 2 we can cancel because of axiom number 1. If you add minus 2 to both sides, 2 get cancelled. Therefore angle 1 is equal to angle 3. This implies that angle 1 is equal to angle 3. Observe the figure. Where is angle number 1 and angle number 3? So in a right angle triangle, if you draw a perpendicular from the right angle to vertex to the hypotenuse, then see that angle number 1, that is angle BAD, is equal to angle number 3, that is angle number DBC, because of axiom number 1. Okay, so angle 2 is common. Therefore, angle 1 and angle 3 became equal. Now, in the same figure, look at the figure. Let us suppose that angle C, that is angle BCD, let it be called as, for brevity, let us call it as angle number 4. Okay, in right angle triangle BDC, since angle BDC is 90 degrees, we can say angle 4 plus angle 3 has to be 90. It's quite obvious because it's a right angle triangle. But angle 2 plus angle 3 is also 90 degrees because angle ABC is 90 degrees. So here in these two equations, angle 3 is common to both. Okay, now if you cancel angle 3 on either side, so we get angle 2. This implies that angle 2 is equal to angle 4. Okay, so with the help of axiom number 1, we could show that in a right angle triangle, if you draw a perpendicular from the right angled vertex to the hypotenuse, then angle 1 and angle 3 are equal, angle 2 and angle 4 are also equal. Okay, so this axiom number 1, children, is also called as, can anybody tell me, in algebra it is called as transitive property. Okay, if A is equal to B and B is equal to C, then A is equal to C. This is called transitive property. So in algebra we call this as transitive property, but whereas in geometry we call it as axiom number 1. Okay, now let's go to axiom number 2. Okay, if equals are added to equals, then the wholes are equal. This is axiom number 2. Don't you think it is very obvious? Without any debate, without any question, okay, with all confidence, we say yes, it's a true statement. So axioms are nothing but scientific statements which are accepted as true without any logical proof, without any argument. We will be convinced, and such statements are called axiom number 2. Here is a small explanation for this. Before that, here is in Kannada. Okay. Now, look at this physical balance. It is in equilibrium position. So, this is the left pan. Let us call it as some object we have kept. Here it is called A and here it is B. Since the balance is in equilibrium position, A and B are equal. Okay. Now, if you add in the same physical balance, if you add C to the left hand side, then left hand pan will become more. But if you add the same quantity to the right hand pan also, then A plus C on the left pan will also be equal to B plus C. So A is equal to B. An equation can be thought of as a physical balance. You add equal quantities to both the pans, to the left and the right. As long as we add equal quantities to both the sides, then also even after addition, the left and the right sides are equal. Hence, axiom number 2 says if equals are added to equals, the whole are equal. That is the meaning of axiom number 2. So, look at the axiom number 3, children. Instead of addition, if you subtract also, then the remainders will also be equal. If equals are subtracted from equals, the remainders are also equal. Okay, the same thing is in Kannada now. So, the same thing can be understood with the help of the physical balance. A, B are equal, left hand and the right hand pans are equal. The physical balance is in equilibrium. Let us remove C from both sides. Then right side will become more. But if you remove the same quantity from the right pan also, then the left and the right hand sides will be equal. So if A is equal to B, then A minus C will also be equal to, after subtracting also, they will be equal. The order relation holds good. Before subtraction, they were equal. After subtraction, also equal, because we are subtracting equal quantities from the both the sides. This is axiom number 3. Let us see some small application of axiom number 2. So in right angle triangle ADB, we have seen this figure already. So 1 plus 2 is 90 and 3 plus 2 is also 90. Let us subtract from both the sides angle 2 only. So 1 plus 2 minus 2 is angle 3 plus angle 2 minus angle 2 plus angle 2 minus angle 2 got cancelled, and on the right side also they are getting cancelled. The reminders are, it is just angle 1 is equal to angle 3. So this is the small application of axiom number 2. Now axiom number 4. Things which coincide with one another must be equal. So look at this small segment. Here is another segment of equal length. So if you superimpose this like two line segment one on the other, they will definitely coincide. Since they are coinciding, we say that they are equal in length. Okay, one more figure you are seeing this. So even these two line segments, if you superimpose, they coincide each other. Since they coincide, they are equal. It also means if they don't coincide, they are not at all equal to each other. So the fourth axiom is, things which coincide with one another must be, will be equal to one another. So okay, see now that has been, this line segment has been placed on that, it is coincided perfectly. Therefore we conclude that those two line segments are equal. Okay, the same thing in Kannada also. Okay, now look at these two triangles, man. So here are two triangles. If you superimpose one on the other, see, if you superimpose one on the other, they are coinciding exactly. Therefore we say that those two triangles are said to be congruent. Let me go back once again and show you this motion once again. Here are two triangles. Okay, we wanted to know whether they are congruent to each other or not. Just transpose one triangle on the other like this. See, they have coincided with each other. Okay, all the sides and all the angles are equal. Therefore we conclude that those two triangles are identical to each other. If they are identical, we use the word congruent. Okay, the last axiom, children, axiom number 5. The whole is always greater than the part. Okay, don't you think so? So to understand this, I got some image for you. Here is the map of our country. What a beautiful shape our country has. Okay, now this is our country. Now look at the map of our state, Karnataka, which is a part, one of the important state of our country. So Karnataka is just a part of the country. Therefore, Karnataka is definitely smaller than the country India. So the whole is our country. Karnataka is just a part of this country. Therefore, we say that Karnataka is smaller than our country. In general, we can say the whole is always greater than the part. Okay, there are some more things are there. You can see in this slide all the 5 axioms. So try to remember these 5 axioms only. Okay, let me conclude, children, now. Okay. Okay, children, so far, 1 minute. Okay, so far in this session, we have discussed seven definitions and five axioms. It's already 1 hour over. So, in my next session, I would like to share with you five postulates and the rules also. Thank you being with us. Any queries, any doubt, any questions regarding any chapters of mathematics, you can send me or send it to the principal also, so that we can discuss, share our ideas regarding that. So thank you very much. See you in the next session. Thank you, children.